Let's go. I really got the feeling today that everything is going my way. Now this is what I'm talking about. Every time I see your smile, it makes me shout. Let's go! Let's go! Nothing's gonna stop us today. Get on the bus or get out the way. We're cruising with the radio on. So turn it up to 10. Here comes our favorite song. Let's go! Let's go! Let's go! Let's go!
Welcome to another Tuesday. Exciting as always. It is another episode of IoT Tuesday, and I am yours truly, Samuel Adranye. It's been a very awesome week. Lots of crazy stuff going on, politically, economically, all of it. Think about it, and as also interesting technologically for me. A lot of interesting things going on. Well, as you know, in our show we try to give you the best. And on this episode of IoT Tuesday, when we come back today, we're going to see how to connect a dust sensor to an Arduino, which is in connection with building a home environmental monitoring system, which you all agreed to. So when we come back, we're going to see how we can connect our dust sensor to our Arduino. Awesome. So we are back. Well, before we get into it, couple of announcements as usual, as you know it. Well, if you haven't heard, well, I'm telling you, come 15th of February, it is the Global Power Platform Bootcamp, globally hosted worldwide by local communities, and here in Ghana is hosted by the Accra Power Platform User Group, of which yours truly is one of the organizers. If you missed our last session, you don't want to miss this because this is going to be power packed. Lots of hands on, lots of hackathon sessions, use cases. All you need to do is come with your laptop, come with your ideas, come with your use cases. Let's build it together. Well, also, I kept telling you that something big is happening in the space of IoT in Africa, specifically Accra or Ghana and Nigeria. Be looking out for the Geek Store. We are almost wrapping up with launching it. So you're going to have the opportunity to buy all your sensors, your microcontrollers, anything IoT you're going to get from the Geek Store. And like I mentioned, excitement for me this week because let me take you to the bench. Because for those of you who've been following me on most of the things I do, I have been using this flick button for, a very, very, very long time. Like almost all my demos I do for Power Apps, Power Automate, Logic Apps, functions, IoT. This button has some really, really strong sentimental values for me. So if you know me very well for most of my demos, you would have noticed that I like using this button a lot. Well, guess what? I got myself Flick 2, which is the next generation of the Flick buttons. It's exciting. I've just been, there's a lot of things I want to build. This goes to tell you that there's a lot coming up for the IoT show as well as Power Automate because I'm going to use this to do a lot of automations. I know Brian has asked me, is waiting on stuff that I'm going to be doing with it, but yes, there's going to be awesome and awesome stuff. I want to use this opportunity to shout out the the producers or the manufacturers of the Flick button, guys. Thank you so much. we've been connecting, something is going to happen. So hey, thanks so much for hooking me up. I very much appreciate that. Well, so with this out of the way, now I think we can go straight into the game. Let's go ahead and connect. Let me push this here. We're going to get back to this subsequently pretty soon. Okay, so in today's episode, we're going to learn how to connect the dust sensor to the Arduino. So if we come back to the bench, a few things you would notice that we have our ever popular Arduino Uno, quite simple right here. We have this, and then we have our Seed Studio base shield because we're using a Seed Studio dust sensor, and this has the J tag, so easier for us to connect. So pretty much this is all we need. So as always, I'm just going to go ahead and connect. I usually don't take it off, but I just wanted to illustrate this to you guys. That's why I took it off this time around. So let me make sure I get this connected properly. The other day I actually, broke one, so I'm a bit cautious not to break this one as well. Okay, it looks like it fitted perfectly. Cool, awesome. Yep, there we go. All right. So we have this, and then now we have, so this is actually the PPD42 dust sensor. So it actually is able to give you some values for the parts per millions of particles or dust in your environment. So we're going to also use this, and this is what we're going to connect today. So as always, we go to the manufacturer side, look at the documentations, and then obviously we pick sample code. So let's just get right into that. So let's go right here, and yep. So let me bring up the URL to that item. And don't worry, you're gonna, once the Geek Store gets rolling, you can buy all these things from the Geek Store. As of today, this is, I think, it's just about $11.50 to buy from C Studio website. But very soon, you can purchase this in Nigeria and Ghana from the Geek Store, right? So a few things, just take a look at it. Groove dust sensor. It provides a reliable data for air purification systems, easy maintainable pulse width modulation output, groove compatible interface, compatible, is compact and light design. Yeah, quite interesting. Let's look at a few pictures of it. Well, there's a real thing on the bench, so I mean, but yeah, this is the resource to it. Now, so it just a few descriptions, a little descriptions to it. Let me zoom this in so we can see this very well. Yep, I hope you can see this properly. Awesome. So it says that dust sensor gives a good indication of the air quality in an environment, okay, by measuring the dust concentration. The particular matter level, the particulate matter level, PM level in the air is measured by counting the low pulse occupancy time. So this is just the mechanism it uses to, determine, the concentration of dust or, or let's say bad air quality, right? Now, in a given time unit, now LPU's time is proportional to PM concentration. So this is just giving us some yada 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 stuff. Well, yeah, we want to go ahead and connect it. So it's groove compatible, as you can see. It's triggered by a 5 volt. Actually uses a pulse width modulation output, so PMW. And as you can see, applications, air purifier, air quality monitor, air conditioner, and yeah, and then ventilator. So as part of our home monitoring system, this plays or fits in very well. So we would want to use this. Now, so these are the platforms supported. It doesn't support BeagleBoard Raspberry Pi Link. It supports Arduino. More reason why we are doing this. That's why I'm choosing to do this with Arduino as of now, and then send the data over to, let's say, Azure Sphere, and then we push the data to Azure. That's why I'm connecting to the Arduino. Okay, so there's just a few fact sheet about it, and then hey, you can look that up. All right, so let's go to documentations as we always do. So this is a data sheet. This is there's some more information about it. air quality monitoring. So these are like resources people have done with it. Actually, let's see. Let's open a few of them because we're going to borrow some code. And hey, and in this era of being productive and you not wasting time, okay, don't try to reinvent the wheel. Libraries have been created, so go find the libraries that work for you, pick the parts of the code that work for you, and then use them. All right. So let's go to learn, and this is just different implementations of it. Smart crops implementation, air quality box, air quality text box. We're building something similar. So groove that sensor. Okay, so let's read more. Here, all we're trying to do is just get some information about it. All right, let's go see what others have built with it. So, yeah, so they have plotted the graph. So what we're going to do is we're going to plot the graph, but the graphs are going to be plotted in IoT Central in Azure. All right, so yeah, some cool stuff. Okay, cool stuff. We are after the library, so let's just go ahead and yeah, this is what people have. It's just showcasing it, placement, sensor output. All right, so they are using some cardboard, read some values in it, parts per minute. So not bad, cool. All right, okay. Some other cool applications that have been built with it. Okay, yeah, connecting to the ground. Awesome. Well. So these are some projects that have been done with it. Okay, so let's go straight and see if we can get. There we go. All right. So let's do some stuff with it. We're ready to get going. So we're going to need our shield, our Arduino, our shield, and our groove sensor, which we already have from the bench I showed you. So we're going to connect it to port actually D8, which is a digital pin 8. So let's go to the bench right now. So digital pin 8. Let's look at that. Yep, there we go. So this is pin 4, pin 3, pin 2, UART, pin 8. So right here, digital pin 8. Let's make sure we're connecting it, correctly. Yep. So now it's gone to digital pin 8. All right. There we go. Keeping it simple. So setup is done. All right. And then plug the group. We've done this. Now let's connect it to the PC. And here is our power. Let's power this up. Let's power this baby up. And don't forget, if you have any questions, please feel free to ask me the questions. I'll be more than grateful to answer them for you. So now we've set it up. Pin 8, digital pin 8. The dash sensor is connected. We've connected the Arduino to our PC. So now let's open our Arduino and let's get some code. Quite very simple, all right? And then I would actually explain everything we are doing. Okay, so let me switch back here. Let's go and open our Arduino IDE, not the Arduino app. And like I showed you the last time, anytime you're starting your Arduino app or you start it up, ensure that you're actually connecting to the right, you're using the right COM port for the Arduino, all right? Cyberman T, welcome to the stream. Thanks for joining us. Hope you are picking something from what we're doing today. So, as you can see, we've opened the Arduino IDE and it's still showing our previous temperature stuff. So I'm just going to make sure that we're on COM port 10 for the Arduino, and I mentioned that you can do this by actually right clicking on your computer, go to your PC, go to properties, go to device manager. You saw it and you had to join it. Thanks. Appreciate it. Let's know if you have any questions that we can answer. So if I go to COM port, you can see Arduino Uno is on COM port 10 right here. All right. You can see that is right here on COM port 10. So I know that is on COM port 10. So let me go back to the Arduino and then a new sketch. Open this up. So by default, when you open the Arduino app, this is what you get, just kind of like a blank, work area. So to make sure that you are getting everything connected, let's go to the port. So in our case, COM port 10 for Arduino Uno is correct. And then on the board, we know we are using an Arduino Uno. So all is set for moving the sketch and all that. Now, remember we put it on digital pin 8, all right? So that's where we're going to connect from. So let me go ahead and paste in some code, and then we're going to go through this code. So here, as you can see, the first line here is telling us the pin which we are connecting the sensor to, which is the pin 8, all right? And here we are declaring some variables to look for the duration, the start time, and then the sample, the sample time. So we're sampling every 30 seconds, all right? I mean, you can change the sample rate if you want to, depending on how we're building application, but we will keep it to like 30 seconds to sample it, all right? Or we can sample it every minute if we want to, so that'll be like 60. And then this is the low pulse occupancy. So this is what it's tracking how many of the parts per million particles we are loading into the sensor. And then the ratio and concentration. So we're going to do some calculations in here. Now, as part of the setup, we're opening a serial port so we can see this in our serial monitor when we run the application. Ideally, it will not be showing in a serial port. We are going to, if I bring you back to the bench just for a quick, we have these two displays here. So in subsequent episode of the show, we're going to connect this, and then instead of displaying into the serial monitor, we'll be using these displays. I also have an LCD screen which will be connected to create the UI for the entire home automation, which we're going to build in C# on WPF. We're going to build that on WPF, and then we'll use that to control or get access to it. We're also going to build a power apps, an Azure power app, sorry, Microsoft power apps, to just check on the go, and then also some power automate so that you can actually send some signals to either turn things on and off, or enable things happening in the house. So that's just an FYI that's going to happen. All right. Okay. Awesome. All right. So let's get back to this now, and then we are setting the pin mode to an output. So we are saying that the pin that we are connecting at 8 is actually an output, sorry, an input pin, because we are reading data from the sensor and that is coming into our Arduino. So it's an input pin, all right? If we, let's say something like a relay will be an output, something like if you're connecting a servo motor, all right, that is going to be like an output. But this one, we're getting data from the sensor into it, so the direction is an input, all right? Just and then start time, we're going to get the current time, and we're setting it up, and the duration, so setting the ping to low, and then we can start doing some calculations with this. And then we are saying that if the time minus the start time is greater than the sample rate, which is 30 seconds, then we're going to get all this information again and then cycle it. So this is going to continue until we turn off or shut it down. So we're using the spec sheet curve, which I'll show you. Let me show you the spec sheet curve right here. So this is the spec sheet curve. All right. So this is kind of like a chart that will tell us, so it's going to guide us that, okay, based on the values we are getting, are we in the green or are we in the red? All right. So this is what we're going to use to determine the values we have to tell us, well, is the concentration too high, or is the percentage of, is the ratio too high for us, and do we need to vacate the building? And we mentioned that we would also be connecting this RGB LED strip as well, so that we can use that as a visual indicator for when things go wrong. Cybermate, have you played around with threading on? Actually, not yet. But I plan to. Do that. I've seen something being done with some RTOS and something crazy, but I plan to do that. I have that, I think, somewhere here. I think we have that actually lined up. Yep. So let me switch back here so you can see. We have a few things lined up. So we have the ESP32 right here. All right, as you can see that, and we have a bunch of stuff lined up. If you joined the stream earlier on, we also have the Azure Sphere here, which is going to be like our master, our master board as well. We have a lot of we have a lot of the particle mesh stuff going on, which we are also going to use. So there's a lot at stake on this channel. So yeah, just join us, and you're going to have a lot of fun. Okay. I mean, once you mention it, Mentee, I will try, to get that going. I'll probably write an article or something and post that for you guys. Okay, so this is the chart we're using. So now that we have that, we can actually plot, we can plot this on it. So let's go ahead. And what do we do once we have this? Let's save this. Let's go up one level. I think we put this in our T. Think is let's look for, yep, IoT. Let's go to sketches. I'm gonna create a new folder here, and then that'll be, we'll call this dust. Okay, and then we're saving this here. All right, so looks like we're on course. So what do we do? All we need to do now is to verify everything is okay with this code. Everything, if everything goes well, this verification shouldn't take long. Yep. And then let's go ahead and now upload it to our Arduino. And that happens. Now let's go to tools. Let's open our serial. Oh, I opened the wrong thing. Let's go to here, serial monitor. Okay. And obviously, let's get this started. So let's see what we print out. Yep, low pulse. Okay, so now I think we have it correctly deployed. Let's see. Pin 8, let me be sure that we connected this to pin 8. Sample it every 30 seconds. Okay, so let's go ahead and, well, this is already deployed, so let's go to tools and open this out. Did I open the, oh, I think I opened the serial plotter again instead of the serial monitor. So, yep, there you go. So yeah, let's keep this here. And 30 seconds, let's 960. Just be sure that the baud rate, yeah, 960. Sometimes, if you have the situation where it's not displaying in the serial monitor, you're better off checking the baud rate on the serial monitor down here. And in our case, it's the same, so that's fine. We just have to wait a bit. So whilst that's going on, if you have any questions, let me know. And there you go. So as you can see, we have our first reading. And because the sample rate is every 30 seconds, it's going to wait 30 seconds before it samples the data. So let's take a look at this. Whilst this is running, so that's a lot, 3730. Okay, so now let's go back to our chart. Let's go back to our chart. So the low pulse occupancy represent the low pulse occupancy time as detected in 30 given seconds. Ratio reflects which level of the low pulse occupancy time takes up the whole sample time. Concentration is a figure that has a physical meaning. It's calculated from the what? Characteristics graph below by using the LPO. So let's take a look at this concentration. We are within the 3000. All right. So this is like smoke cigarette characteristics. So there are different characteristics we can look at, and I'm going to share I'm going to actually share documentation on the various characteristics so that whatever value we get, we can detect and know what signature of particle or dust we are picking up or smoke we're picking up. It could be cigarette, it could be something else, so we can properly report on that. So we are somewhere within the 3000. Let's bring this back in view. Yeah, so somewhere, yeah, as you can see, so 6,000, 7,000, 3,000, so 6,000, so between 7 and 6,000 thereabout. Well, let's see. So, um, yeah, 7,000, 6,000, 7, yeah, somewhere here, about 6% smoke. Well, that's possible because I have one of my windows open and it's probably there's something going on out there, so it's quite possible something is coming in. in there. Yep, yep. Well, particle size over 1 micrometer. So, as you can see, people, we have connected our dust sensor. We're getting values from it. That's the first step into building our home environmental monitoring. Now, subsequently, we're going to learn how to connect. I'm going to show how to connect the LED and then routing the data onto one of these displays in the next episode. And then after that, we'll now come back to the table and look at the setup for our home environmental monitoring system, because now we're able to connect all our gas sensors. We've seen how to collect our dust sensor, which are these are the key things that we need for the home environmental monitoring system. Now, once we have done this, it's all going to come together. We're going to put all of them together and then start reading values, sending them into Azure, and then building some Power BI graphs, putting some AI analytics into it, and then just trying to figure out how best we can create a system that can help us keep our homes very safe and nice to live in. Well, if there is any question, as usual, let me know on the channel and we can do something else. But for now, let's enjoy this for a while, and I'll be up to take a few questions before we say goodbye. Today has been quite a short one because yes, we're building upon the home environmental monitoring system in increment, bit by bit. Well, until I come your way again next Tuesday with another episode of IoT Tuesday, this has been yours truly, Samuel Adjani. Catch you next Tuesday.